This is Math in Class with Ma'am MC, Ma'am Forts, and Sir Reynold. Happy New Year! Welcome to another year of unlocking new ideas and knowledge in mathematics. So today, I will be discussing MathPacks for Grade 9, Quarter 1, Week 6C. The objective of this discussion is the learner represents a quadratic function using graph and equation. Now, here are some key questions for our discussion. What is a quadratic function? What is the graph of a quadratic function? How do we represent the quadratic function using its graph? How do we determine whether the given equations represent the quadratic function or not? What is an axis of symmetry? What is a vertex? So by definition, a quadratic function is a function that describes a polynomial of degree 2. So remember always that quadratic function is in second degree. This will set the quadratic function apart from all other functions. It is defined by y is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a must not be equal to 0. Now sometimes in place of y, we have the f of x. So we have f of x is equal to ax squared plus bx plus c. Now, they mean the same. They are still quadratic function because y is just equal to our f of x. Now, a quadratic function, y equals ax squared plus bx plus c, can be represented by a graph and equation. So the graph of a quadratic function is a parabola. A parabola is a U-shaped curve. So the parabola opens upward if a is greater than 0. A is greater than 0, that means to say your a is positive. So the leading coefficient in your function is positive. Then the parabola opens upward and it looks like this one. Now the parabola opens downward if a is less than 0 or if your a is negative. So if the coefficient of x squared here is negative, then your parabola opens downward and it looks like this one. Parabolas have common characteristics. It is aligned to the axis of symmetry, which divides the parabola into two parts such that one half of the graph is a reflection of the other half. So take for instance, we have here our Cartesian coordinate plane. We are going to graph our parabola. This line, this vertical line, which divides your parabola into two parts such that this part is equal to this part, is called your axis of symmetry. So you remember, your axis of symmetry is a line and it divides your parabola into two parts. Now, your axis of symmetry looks like this one if your graph or your parabola opens downward. So the parabola has a turning point called the vertex, which is either the lowest or the highest point of the graph of the quadratic function. So if the parabola opens upward, the vertex is the minimum point. So this is the vertex of your quadratic function or the graph of your quadratic function, and this one is the minimum point or the lowest point of the graph of your quadratic function. If the parabola opens downward, the vertex is the maximum point. So here, in this kind of parabola, this is your vertex, and this vertex is the maximum point or the highest point of the graph of your quadratic function. Now, as a summary, if a is greater than 0 or if your a is positive, then the graph opens upward or the parabola opens upward, and the vertex is the minimum point or the lowest point of the graph of your quadratic function. Now, if your a is less than 0 or if a is negative, then the graph opens downward. Your parabola opens downward. And the vertex is the maximum point or the highest point of the graph of your quadratic function. Now, to sketch the graph of a quadratic function, the following steps are suggested. Step 1. Construct a table of values for x and y. Step 2. Plot each ordered pair of values on the Cartesian coordinate plane. Step 3. Connect the plotted points with a smooth curve. Label the graph. Let us have the first example on your MathPacks. So represent the quadratic function y is equal to negative x squared plus 6x minus 5 using its graph. So here is the solution. So step 1 again is to construct a table of values for x and y. The quadratic function y is equal to negative x squared plus 6x minus 5 can be represented by the table of values below. So we have here two rows of values. We have the values of x and the values of y. For your x, we have 1, 2, 3, 4, and 5. And then for your y, we have 0, 3, 4, 3, and 0. Now, how did we get these values? Now, for your x, gusto ka mo, you can have any numbers, any real numbers. So, in this case, we have used 1, 2, 3, 4, 5. Now, how did you get the y? So, how did we get the y? So, the values of y will depend on the values of x. So, what should we do? We need to substitute each value of x into our function to get the value of y. Now we have here values for our x. You are free to choose the values of x, then substitute it into our quadratic function to get the values of y, or you can do the opposite. Assign values to our y to get the values of x. Now in this case, it will be easier for us to assign values to our x, then substitute it into our quadratic function to get the values of y. Now, if we let x to be equal to 1, then we have here our quadratic function, y is equal to negative x squared plus 6x minus 5. Again, substitution means we need to replace every x here in our function by 1. So we copy y, then the equal sign and also the negative sign. We replaced x by 1 because x is equal to 1. So that is 1 squared plus we copy 6. Then we replace x by 1 again. So that is 6 times 1. Then we copy negative 5. After that, we simplify. So negative 1 squared. Remember, it's just the one that is being squared. So we just have to copy the negative sign, then simplify 1 squared. 1 squared is equal to 1. Then we have plus 6 times 1 is equal to 6. And then copy negative 5 or minus 5. Then we simplify again. Negative 1 plus 6 minus 5. So notice, negative 1 and negative 5 are like terms. So we can combine them. Combining them, we have negative 6. So negative 6 plus 6. Remember, they are different or the same numbers but of different signs. So if you combine them, the answer is always 0. So our y is equal to 0. So if your x is equal to 1, then the value of y is equal to 0 if we have the function y is equal to negative x squared plus 6x minus 5. So again, our y is equal to 0 if x is equal to 1. Then we try for the value of x which is equal to 2. So if x is equal to 2, we do the same. We substitute the value of our x which is 2 into our quadratic function. So we have here y is equal to negative 2 squared plus 6 times 2 minus 5. Then we simplify. So copy again the negative sign. 2 squared is equal to 4. 6 times 2 is equal to 12. And then we copy negative 5. So negative 4 plus 12 minus 5. We combine negative 4 and negative 5, and that is equal to negative 9. Negative 9 plus 12. So remember, 9 is negative, 12 is positive. So if we try to combine them, we need to subtract. 12 minus 9 is equal to 3. Then we copy the sign of 12 because 12 has the greater absolute value. So we copy the sign which is positive. So that is y, we have here our final answer to be positive 3. So if our x is equal to 2, then our y is equal to positive 3. Then we also have x is equal to 3. So we do the same. We just substitute the value of 3 or the value of our x which is equal to 3 into our quadratic function. Then we get our y which is equal to 4. So if your x is equal to 3, then y is equal to positive 4. Then we have x is equal to 4. So again, substitute it in our quadratic function. Y is equal to negative x squared plus 6x minus 5. Then we have here the value of y which is positive 3. So if your x is equal to 4, then y is equal to positive 3. And then lastly, we have x is equal to 5. Substitute again the value of x which is equal to 5 into our quadratic function. Y is equal to negative x squared plus 6x minus 5. Then we get y is equal to 0. Now we will be getting our ordered pairs. Our ordered pairs. Now, in getting our ordered pairs or in making our ordered pairs, remember, the first element is always the value of x. So we have here, the first ordered pair is the pair of 1 and 0. 1 is our x, y is our 0. So we have the first ordered pair to be 1, 0. Second ordered pair is 2, 3. So the value of our x is 2 and the value of our y is 3. Then the third ordered pair is 3, 4. So we have here 3, 4. And then we also have 4, 3. And we have 5, 0. So we have 5 ordered pairs in total. Now we need this ordered pairs. Remember, these ordered pairs are representation of our points. So we can plot our points using these ordered pairs. So it is very important to get the ordered pairs in our problem or in our function or in solving this kind of quadratic function. So again, we have here 1, 0, 2, 3, 3, 4, 4, 3, and 5, 0. We are now ready to graph our quadratic function. Step 2. Plot each ordered pair of values in the Cartesian coordinate plane. The ordered pairs are 1, 0, 2, 3, 3, 4, 4, 3, and 5, 0. Now for the first point, we have here 1, 0. So since x here is positive, because 1 is positive, then we are moving one step to the right side. So it's here. Now, since our y is equal to 0, then our first point will lie on our x-axis. So our first point is located here. Now for the second point, since 2 is positive, then we will be moving 2 steps to the right side. So we have 1, 2, and then since 3 is also positive, we will be making 3 steps upward. So we have 1, 2, 3. So our second point is located here. And then for the third point, we have 3, 4. So since both are positive, then we will be moving 3 steps to the right side. 1, 2, 3. Then 4 steps upward. 1, 2, 3, 4. So our next point is located here. And then we also have 4, 3. So 4 is positive. So 4 steps to the right side. 1, 2, 3, 4. And then 3 steps upward. 1, 2, 3. So our 4, 3 is located here. And then as for 5, 0, it will be the same as 1, 0. It will lie on the x-axis, but our point will be located here. Now here are the 5 ordered pairs or the 5 points on the Cartesian coordinate plane. Now our step 3 would be to connect these plotted points with a smooth curve. So we will be making our parabola. So our parabola will look like this one, and then we need to label the graph. So again, this is the graph of our quadratic function. Y is equal to negative x squared plus 6x minus 5. So this is our parabola. So remember, as what I have discussed just a while ago, if the parabola opens downward, our a is negative or is less than 0. So our a here is equal to negative 1. So that is the reason why our parabola opens downward. Now, this point, which is the highest point or the maximum point of the graph of our quadratic function, y is equal to negative x squared plus 6x minus 5, is our vertex. And again, it is the maximum point or the highest point of our quadratic function, since our a is less than 0. And then if we are going to make a line which cuts our parabola into 2 equal parts, such that this side is a reflection and this side is our axis of symmetry. So remember, our axis of symmetry is a vertical line, and this axis of symmetry also passes our vertex. So remember again, our axis of symmetry is a vertical line which passes our vertex and divides our quadratic or the graph of our quadratic function or our parabola into 2 equal parts. Now let us have exercise number 1. But this exercise again is not from your MathPacks. So this is just another example. So you can answer the exact exercise on your MathPacks later. So represent the quadratic function y is equal to x squared plus 4x plus 3 using its graph. So here is the solution. Again, we'll follow the step. So the 3 steps. So step 1 is to construct a table of values for x and y. So the quadratic function y is equal to x squared plus 4x plus 3 can be represented by the table of values below. So we have here, again, we will be assigning values to our x to get the values of y. So I have assigned x as -4, -3, -2, -1, and 0. So we are going to substitute these values of x into our quadratic function y is equal to x squared plus 4x plus 3 to get the values of y. Let us substitute. If x is equal to -3, then we have here our quadratic function y is equal to x squared plus 4x plus 3. So again, we need to substitute the value of x, which is -3, into our quadratic function. So we replace every x here by -3. So we have y is equal to -3 quantity squared. So remember, we have enclosed our value of x by a parenthesis or into a parenthesis. That means to say, the entire -3, the sign and the number is being squared. So if you are going to square this one, then you will have -3 times -3 plus 4 times -3 plus 3. Then we simplify. -3 quantity squared is equal to 9, and that is positive because remember, the whole -3 is being squared. So we are not just squaring the number but also the sign. So -3 times -3 is equal to +9 because negative times negative is equal to positive. Then we also have here +4 times -3. So +4 times -3, so 4 times 3 is equal to 12. Positive times negative is equal to negative. That is why we have here -12. Then we copy +3. Then we combine like terms. 9 and 3 are both positive. So we try to combine them. 9 plus 3 is equal to 12, and that is positive 12. 12 minus 12, or combine it to -12, we will have 0. So if our x is equal to -3, then the value of our y is equal to 0. So our first ordered pair later will be -3, 0. Then let's have -2. So again, substitute the next value, which is -2, into our quadratic function. So substituting the value of our x, which is -2, into our function, we will have y is equal to -1. So if x is equal to -2, our y is equal to -1. So our second ordered pair later will be -2, -1. Then we proceed to our next value, which is x is equal to -1. So if we are going to substitute our value of x, which is equal to -1, into our quadratic function, then we will have y, which is equal to 0. So our next ordered pair will be -1, 0. Then let's have our 0. So if x is equal to 0, then we try to substitute this value of x into our quadratic function, our y is equal to 3. So our next ordered pair will be 0, 3. And then lastly, if x is equal to 1, then the value of our y is equal to +8. So we will have the next ordered pair to be 1, 8. Now, our ordered pairs again are -3, 0, -2, -1, -1, 0, 0, 3, and 1, 8. We will be using this one to plot our quadratic function. Now, step 2. Plot each ordered pair of values in the Cartesian coordinate plane. So again, our ordered pairs are -3, 0, -2, -1, -1, 0, 0, 3, and 1, 8. So we have here our Cartesian coordinate plane. So again, we will be plotting each ordered pair. So first we have -3, 0. Since your x here is negative, then we will be making 3 steps to the left side of our Cartesian plane. So we will have our first point here, because our y here is equal to 0, then it will lie, or our point will lie on the x-axis again. So we have here -3, 0. Then we also have -2, -1. So -2 is, 2 is negative. So we will be moving 2 steps to the left. So we have here 1, 2. And then since your 1 is also negative, then we will make 1 step downward. So we have here 1. So our next point will be located here. Then we also have negative 1, 0. So 1 step to the left side, and then it will just remain there because it will lie on the x-axis since our y is equal to 0. Then we also have 0, 3. So our next point will be lying on our y-axis. And then we have here 3. So 3 steps upward. So 1, 2, 3. So 3, 0 is located here. And then we have your 1, 8. So 1 step to the right side. So we have here 1 step to the right side and then 8 steps upward. So we will have it somewhere here. So there you have it, our points on the Cartesian coordinate plane. Then step 3 would be to connect the plotted points with a smooth curve. Then we label the graph. So we will be making our parabola, and it will look like this one. And then again, this is the graph of our function y is equal to x squared plus 4x plus 3. Then this point here, the lowest point on our graph is our vertex, which is also the minimum point. And this line which passes our vertex and which divides our parabola into two equal parts is called the axis of symmetry. So example number 2, determine whether each of the given equations represents a quadratic function or not. So we have here a table. On the first column, we have here the equations. On the second column, we are to tell whether our given equations represent quadratic function or not. And we need to justify our answers on the third column. Now let us have the first equation. We have y is equal to 3x minus 7x squared plus 9. Now, is this a quadratic function or not? So we have here, it is a quadratic function. So what is the justification? So it is in second degree. So notice that in this equation, the highest exponent of your variable x is equal to 2, which means to say that this equation is in second degree. But it does not guarantee that if your equation is in second degree, it is already quadratic function. You need to be sure, or you need to assure first that you have two variables, your y and then your x. Or sometimes, again, you can replace y by f of x. If you have such, then you can say that this equation is indeed a quadratic function. Now let us have your second example. Y is equal to x squared. So clearly we can see we have two variables, your y and then your x. And then your variable x is in second degree, or the highest exponent is equal to 2. So that means to say our equation is in second degree. Therefore, our equation is a quadratic function. Now let us have the third example. Y is equal to x plus 1 times x minus 1. By looking at this equation, we cannot tell whether this equation is in second degree or not. We need to simplify first our binomials. So we are going to multiply x plus 1 by x minus 1. Now try to notice that here, our first term is x. Here, we also have x. Our second term, or our last terms, are also 1, and they only differ with the signs between the two terms. So we have here plus, and then we have here the minus. So we call this one our special product, which is the sum and the difference of two terms. So if you are to multiply two binomials, which resembles to a sum and difference of two terms, then we have a shortcut in doing, or in getting the product of those two binomials. So we only multiply the first terms. So x times x, that is equal to x squared. Positive 1 times negative 1, that is negative 1. So our equation will become y is equal to x squared minus 1. Now, if you're not used to using the special product, you can always go back to the FOIL method. So first terms, outer terms, inner terms, and then the last terms. then you will be getting still y is equal to x squared minus 1. Now, with this equation, we can clearly see that our equation is in second degree. And there is also the presence of y and x variables. So therefore, this equation is a quadratic function. Now, let us have your fourth example. So by looking at the example, or if we are to simplify this expression, negative 3 times x squared is negative 3x squared. Negative 3 times 1 is negative 3. So we will have negative 3x squared minus 3. 0 is equal to negative 3x squared minus 3. So our equation is in second degree. But as you may notice, our variable here is just x. We don't see f of x or y. So that means to say this is not a quadratic function, but a quadratic equation. So it does not guarantee that if your equation is in second degree, then that is already quadratic function. You need to be sure first, again you need to be sure first that you have the variable y and the variable x. Or in place of y, we can have f of x. Okay? Or sometimes we can use other variables, just as long as you have two variables. Now, let's have your number 5. Y is equal to x squared, or x cubed rather, plus 1. So obviously, this is not a quadratic function because the highest exponent of your variable x is equal to 3. So it's not 2, it's 3. So therefore, it is not a quadratic function. So that is how you determine whether your given equation is a quadratic function or not. That's the end of our lesson for today. Thank you for your patience in trying to understand our lesson. So we promise to help you in every possible way there is. So that is all for this video. See you again in the next video tutorial. Bye!